Ladies and gentlemen. Hello and welcome to the blockchain information session. That date is incorrect. That was last month's information session, but we appreciate you joining us on February 3rd, 2022. And I have Jim Sullivan with us here. Jim is our CTO. Like I said, he's an author of Programming and Solidity book, and he's working with a number of protocols on creating their curriculum as well as their assessment towards certification to really onboard their on-ramp. So you're gonna hear a lot more from him on the second half of this little information session, but I will lead us off here. So we're all familiar, or at least in the news, we're hearing a ton about Bitcoin, and we're seeing this symbol and it's all over social media, but what is the real value here? Is it valued because everybody else thinks it's valued? Or is there some underlying technology that is really driving this adoption and perceived value? So real quick, a couple quotes. So the blockchain is the most consequential technology since the internet. I like this quote. The internet is programmable information, of which we know we have way too much, and blockchain is programmable scarcity. So what is really important? What's important to companies or individuals, the end user? That is what blockchain is about. Is about the information it's important to us and how it's stored and shared. So just in terms of adoption in this industry, we're all hearing, crazy stories, hearing a lot more about blockchain in the news and Bitcoin, particularly cryptocurrencies, but you're going to hear a lot more about how blockchain, Web3, is changing how businesses operate, much like the internet, changed really every business to a degree. And we all are becoming technology businesses, whether, even the auto mechanic is now doing digital marketing and things online and tracking parts. And so there's just so many industries that are being impacted by Web3, and the adoption and growth is kind of outpacing a lot of other Web3 technologies. So blockchain seems to be leading the pack because it is the basement. It is the plumbing, so to speak, for Web3. And we've all known about these kind of faster rates of adoption. Heck, as Americans, I don't know if it's all Americans on the call, but we were often leading the pack on, and now the playing field is level so long as you have access to internet. So the adoption worldwide, not just statewide, will be much steeper and faster. So it's on us to upskill and have that lifelong learning mentality to be able to capture the change and take advantage of it. But it's no what do you call it? It's no losing my words. It's no, man. The point is, it's happening much faster, and we're all seeing it, right? We're seeing the change day to day these days. So what is really happening? What is happening in this space? It's not just technology, software. It takes people to develop software. It takes people to get other people to adopt it. So really, it's about the talent out there that's going to drive this. We've already seen a huge gap just in coding, and this is even much further. You have the CNM deep dive coding bootcamp. Everybody coming out of those is eligible for a job, and with blockchain, it's even more so. So if you get these skills, it can't hurt. So back in 2020, although LinkedIn hasn't done much of this throughout COVID, but they listed blockchain as #1, and the previous year wasn't even on the list. So it's even outpacing cloud computing and others that are really have been around for a while. Not that they're going anywhere, but it'll all start to morph into this Web3 properties. The demand is there. So I want to what we're going to do is talk about the demand, talk about some courses CNM's offering, and then we're going to kind of get a little bit into the weeds as to what blockchain is. So hired, seeing a huge growth in engineers. One thing I always like to say is that, if you're not an engineer or a coder on this call, 40% of the jobs are non-technical. It takes business-minded people. It takes community organizers. It takes sales. It takes a lot of people to make this technology get adopted. But first, it's got to be built. And so there's a massive demand. About 60% of all jobs in the space are for engineers, and that's what most of the press is on. But if you go on Glassdoor or any of these sites, even ZipRecruiter that aggregates it all, you'll see the demand for technical versus non-technical. And I encourage you to do it because you'll see what type of positions might kind of leverage your prior experience. So there's just, massive increase year over year over year. So TechCrunch said there's 14 jobs for every actual skilled or eligible blockchain engineer. And that's one thing, is that there's not a lot of verified skills out there. And that's something we're working on with CNM, which I'll get into. But the numbers in every article out there just keep showing a massive uptick in demand here. So if you are a developer, get these skills, because you'll see higher wages and you'll be able to get a job very quickly in this space. Or if anything, get the skills and kind of have a side hustle to get acclimated before, and you build up your CV before you jump into maybe a full-time position with some of these larger companies that are paying quite well. So what is CNM offering? They're offering a lot of programs. The two baseline programs, if you're not quite sure where to begin, would be Blockchain Foundations and or the Crypto Trading course. Crypto Trading course is very much more focused on crypto. Blockchain Foundations gets more into the weeds of what blockchain is, but it's a 15-hour program, so you do get a hell of a lot of information about what it is. You're not going to. It's going to demystify kind of how it works, and what. Then you can see the playing field after Blockchain Foundations to determine which route is best for you to go. In the Crypto Trading course, there's actually a simulator that's included with this program. So we can actually form teams and groups and trade together to learn together. So it's a very exciting thing, and happy to answer questions there. I want to give you some example breakdowns of what's in these courses, and I want to show you kind of the stackability of these things. So as I mentioned previous, Blockchain Foundations 15-hour course is the baseline for all these advanced certification programs, such as Blockchain Business Professional, Project Manager, Developer, and the like. And I'll share more of those in a sec. But so the first three courses of any certification program CNM offers is what we call the blockchain core: Blockchain Foundations, Blockchain and Bitcoin Intensive, and Development Decision. And really, you don't have to be technical to go through those programs. In fact, this entire course set is intended for a non-technical audience. But it's extensive, and there's actually a number of elective options. You'll see here the second to last or last two courses are towards finance, but there's this could also be blockchain for the healthcare sector, blockchain for the supply chain. So you have elective options with CNM for these business professional courses, as well as project manager. You'll notice the big difference between project manager and business professional is really architecture. So we're injecting architecture in here, beyond the strategy, because that's ultimately what a project managers need to understand in order to work with a more technical team to launch a project. And this project manager course too has electives as well. So here we're showing accountants, but like I said, you can have finance, healthcare, supply chain, legal. So the point is, you get your core blockchain project manager understanding, but then from your background or maybe roles you would like to go into, you can select the elective that is of interest to you. And here's the Certified Blockchain Developer course, of which is actually a lot more live hours. And the reason we do that is because it does take a lot of give and take with the instructor to wrestle this information into being, right? So that you, the learner, can actually execute and develop a smart contract, as well as deploy a D app. And so, by the way, a D app is a decentralized application, because that's what Web3 is. It's decentralized. So if you hear D app out there, it's just like any other app. In fact, mobile apps will become decentralized. They'll probably just call them applications, but right now the nomenclature is D app for decentralized application. And so we actually are training towards a number of specific protocols, Ethereum being one of them, Hyperledger Fabric from the Linux Foundation, Corda, certified developer from R3. And then, as I mentioned at the top of the call, Jim's working with a number of protocols, that being Hedera, Algorand. We're in talks with a number of others like Cardano, Polkadot, et cetera, that are all trying to make it as easy as possible for developers to come onto their platform. But right now, it's hard, dense documentation. So it's our job to take that information and provide you a workshop so you don't have to hack it yourself. And we'll take you up the learning curve a lot faster, get you certified and get you employed. So you will see additional badges and certs from CNM in the coming months. Really, Hedera and Algorand will be launched, and a number of other certifications available down the road. So Microcredentials, the BCA, by the way, is the Blockchain Certification Association. The Blockchain Academy, along with the Government Blockchain Association and others, are looking to establish skill benchmarks, which is really important. There tends to be a race to the bottom in terms of what the standards are in a space, particularly something so new. So we wanted to help establish a standard, both at a bite-sized level, micro-credentials, versus certifications that tend to be more robust programs. And so there's a number of universities pointing to that and people hiring based on this cert. So what is blockchain? And this is where I'll hand it off to Jim Sullivan, and I'll still steer Jim, but if you can talk. So Jim, if you quick introduction be great. It is he's on the East Coast there, so a little darker, but he's still with us, working hard.
Great, thanks, Ryan. Well, welcome everyone. My name is Jim Sullivan. I am I'm a software engineer as well as the Chief Technology Officer here over at the Blockchain Academy. So we're building curricula, we're building various applications, products for learning. So we're looking to deliver the hands-on experience of all the blockchain solutions that are out there. Great. So yeah, just from this, we see blockchain is a distributed database. Yes, that's true. It's a very special database. It's a database for things of value. So that may be oversimplifying it, but it's a pretty good summary. Most of the software that's out there is open source. Even the corporate for-profit blockchains still have open source software. It does use cryptography. And like Ryan said, it is a distributed network, so it's peer-to-peer. And it is, I guess you could say, we often think of a ledger as something really simple. However, ledgers actually helped, the fact that we have a ledger really helped society advance because we were able to prove ownership. And once you could prove ownership, you could trade, not only between your own village, but other nations or around the world. So the blockchain technology is that next major increment of the ledger. And it is distributed, no question about that. It runs on a distributed peer-to-peer network. So the blockchain's always up and running. If one node, two nodes go down, doesn't matter. The blockchain continues to run. If any nodes are faulty, they can go offline, and when they come back online, they can be resynchronized with the state of the blockchain. There is permissionless blockchains that I'm sure you're familiar with, like Ethereum, like Bitcoin, like Hedera, and there are permissioned blockchains like Hyperledger, like Quorum. Those are the enterprise blockchains. Corda is also another example of a permissioned blockchain. So those are the private ones, and often they're called consortium. So consortiums of different businesses conduct their transactions in a manner that's permissioned and all of the users are known. They are secure, they're immutable, irreversible. I like the way that's stated there. For the most part, tamper-proof, and because there are always always several copies of the ledger running on the various nodes. They can either be trustless or trusted. However, the distributed nature of the blockchain validates before any transactions are attempted that the items you're transacting, say it's the funds or the coins or the tokens, they are there, both parties have it, and it does validate that the exchange did happen successfully, so that there's no need for that trusted third party. And all of the participants sign the transactions. And certainly automation can be built in. So we can build, as Ryan was saying, blockchain applications, smart contracts, and DApps or dApps, where we can automate a lot of the transactions, a lot of the input for the transactions. In fact, you may have heard the word DAO which is, I guess you could say, the blockchain's answer to a corporation. That a lot of a DAO, the application, a DAO is really just a big blockchain application with a lot of logic to it, but it fosters a lot of automation.
Thank you. And yeah, just to expand upon that, think about this, all the supply chain issues we're having right now. And if a lot of these issues were, with Internet of Things and the like, again, Web3 merging, you're going to have a lot more seamless transactions, right? As soon as something is scanned, the money gets transferred, right? You don't have to necessarily rely on an accountant to execute or that invoice. So there's just so many things, efficiencies that are going to be coming along the pipe here. So where did it start, Jim?
Well, you can see here the very first, let's say the very first popular blockchain, the one that we call the one that's like all the blockchains we have today, was Bitcoin. And Bitcoin began as a white paper written by somebody called Satoshi Nakamoto. And if we take if you can download this, it's right, the URL is right there. You could also Google the Bitcoin peer-to-peer electronic cash system white paper. It's only 9 pages, maybe 9.5 pages, less than 10. So it's interestingly short, considering the large impact that the Bitcoin application has had on our world.
Great. And I'll go to the next slide. We do have a question from Bill, but Bill, let's talk about this at the end. It's regarding credentials on the Lear environment. So I'd love to talk to you about that and the NFTs to accomplish it. But that's a great question, Bill. Here's a good question. Might as well pause real quick. How do you define Web3 from Chris Perkins? How would you define Web3, Jim?
Well, I would say that we know what Web 1 was, right? That was the Internet of Information. Web 2.0 was the blogs. So that was the Internet of Collaboration, or where we can directly communicate with one another, social media, blogs, and so on. So Web 3, or the third iteration of the Internet, is going to be the Internet of Value, where we are going to be able to exchange value and use applications that are that also support us in exchanging value. It's also going to be the peer-to-peer internet too, where we're not dependent upon enterprises that control all our data. We're not dependent on enterprises that host all of the applications we use. The applications will be peer-to-peer. So on these networks, if it's running on one node, it's still up and running. So that really is, I guess you could say, the summary of what we're hearing is Web3. And there are already tools out for it, right? A lot of you may have heard of Web3 tools, Web3.js, and so on.
Great. All right. A little bit more here on blockchain versus blockchain technology.
So it's a network, a distributed database, permissionless. That's the public ones, right? There are permission blockchains. It's a record of transactions in chronological order. Sounds, simple, but it, a lot of it really is. So all of the transactions are ordered, and to validate that, if I purchased an asset, say two of us were trying to purchase an asset at the same time, well, the transactions are ordered in such a way, time-stamped in such a way that we know who actually was able to complete the transaction on that asset. And the blockchain technology, again, is infrastructure. It's decentralized public records that are secure. The public ones are anonymous, but all the public and private are tamper-proof and unchangeable. So it is indeed a single shared source of truth. And we can see here the popular networks, the first networks, and still pretty popular, the centralized ones. These are the classic client server. We have the server right there in the center, and all the clients are around it, surrounding it, and all the clients are dependent upon the server. So if the server goes down, the whole network goes down. And what they do is they relay messages to one another through the centralized server. So that's more vulnerable to attack, and it's more vulnerable to some kind of a fault. And then the next advancement on that was the decentralized server, where you have several replicas of the server running, and they are then relaying messages between the clients. So it's a little more robust than the centralized server, But typically somebody owns the decentralized, so somebody owns the server, somebody maintains them. So they control all of the data that all of the users, let's say the users are the clients, they still control all of the data that the clients administer. And then, but the distributed, completely different, right? There is no centralized node. So it's completely peer-to-peer. They use the protocols or gossip protocols. So they send all the information. Every node sends all its information relative to the blockchain or an application to every other one. It's always up and running. And it's you manage your, each user manages their own data. And we've heard about mining. So mining is one type, and it's still the most, let's just say the highest market share, for lack of a better term, of what we call a consensus. And so it's important to know that there's one copy of the ledger typically, and then there's usually one node type on a public blockchain. So all of the nodes do all of the work to maintain the single copy of the ledger. However, each node hosts its copy of the ledger. So it has to be synchronized for all the nodes. Since it's a single source of truth, they all have to have the exact same data. So mining provides that. And mining also provides something of critical importance that you would read about in the Satoshi Nakamoto white paper. You'd read about preventing the double spending. So the mining process prevents me from taking a Bitcoin and using it for the same Bitcoin for more than one transaction. So that's what the consensus also does, which is something very important, which you don't often hear about. But that's one of the ways that Satoshi Nakamoto solved the double spend problem, because that had been a problem before the blockchain. True digital currency was very difficult because of being able to solve the double spend problem.
Yeah, Elon Musk even talked about it, right? They were trying to solve it back in the eBay days.
Right, eBay, correct, right. But eBay's a payment system. It's not an independent digital currency system. But correct, right. PayPal came out of the very first attempts at eGold, right, DigiCash, and all that, where that problem couldn't be solved. But eBay's just really no different than your own credit card transactions or anything like that. They are the third party for two or more other transactors.
That's right. Get a little more into the weeds here.
Yeah, so we can see here, there's a transaction initiation. So these are the basic workflows here, the verification, and these verifications are built into, I guess you could say, data files, if you want to get really down into the weeds, called blocks. And the blocks have essentially pending, or let's just say completed verified transactions in them. And the proposed blocks before their blocks have pending transactions in there, but the blocks have their all of the completed and final transactions in them. And the way the blocks are created are through a process called mining. I think we talked about that. So the idea behind mining is pending transactions come in, they're validated, and they are then as soon as they're validated, they're created as blocks, and they're chained into each other by really an algorithm called a hash. And the hash data is from the previous blocks. That chain of events, that hash data, it appears in the current block and the block before it, and that's what prevents the immutability of and the unchangeability and of the blockchain. So the security is all built in there. So the public blockchains, those are the most well-known, right? Those are your Bitcoins, your Ethereums, Cardanos, and so on. They're public. Anybody can join. They are anonymous. Everybody gets read, write on there, and everybody participates. And everybody can see what's going on. You can get those blockchain explorers, and a lot of people, in fact, like to do that, watch all the transactions go by. On the other side, I'll just go to all the way to the right there, the private. So the private is everybody is known, all the transactors are known, they are permissioned, so they have roles, and it's either for one enterprise or for a hybrid, as you can see right there. So it's the hybrid is really the consortium. So private and hybrids have a lot in common. They are between, say, Walmart and all Walmart's suppliers together. That partner net, I guess you could say, they've been referred to as well, all participate running the same sets of applications because they have something in common, like a supply chain or so a supply chain. And in healthcare, you might have pharmaceutical manufacturers, and what they would have in common are the products that they manufacture and ship. And then obviously there's some kind of supply chain there, so that would be the hybrid or the consortium. And again, the two primary uses here, the trading of cryptocurrencies, yes, that's obviously the first use case, the first one, the first proven, the highest market share as far as use cases is the trading of cryptocurrencies. And also, though, another important use case is the managing and recording of trade, commerce, and tracking of compliance. So any item of value. We know DeFi now is getting popular. DeFi involves tokenization. So creating tokens from models, I shouldn't say models, from real world objects. So we essentially create a virtual model of a real world object in our blockchain. And we can, those can also be NFTs. So we can embed in there certain data that describes those tokens as unique. And there are also tokens that go with gaming, right? We know that games have coins. If any of you use the web browser Brave, that has a certain token that runs on Ethereum, actually, that will essentially tokenize user attention, allowing you to manage your own data. So, and also there are going to be, in the not too distant future, communities where we have DeFi, meaning maybe us as groups of crypto owners, right? We have a certain amount of crypto. We might lend it out on the network to someone else. So you don't have to go through an institution. You can contact either a consortium or an individual directly, and they might lend you their crypto. And then we already see there are credit unions, banks coming online that are 100% blockchain powered.
Yeah, and just to add to that, all the hypes about the crypto, and there's a ton of interest in it, and people are seeing the value, they're investing in the value of it or trading in many cases. But when you think crypto really has nothing to do with your medical records or the fact that your marriage license, where it's stored, or all the information that's pertinent to you really is separate from crypto, right? That's the valued data that you should then control over time. And imagine, the use cases are crazy, but this could liquefy real estate, right? An asset that's typically really hard to offload. We can tokenize a building and have shares of a building, much like a REIT, but a lot more liquid in terms of who can access that value. So
a deed is a piece of paper that describes a property. We can't put property in our pocket typically, right, and walk around with it to trade it. But so we came up with pieces of paper where we can do that, right? Titles and all that. Well, a token is just the title on the blockchain that's run on a ledger. So I know I can complete a transaction, and we have 100% valid where it's validatable who sold it and who owns it now.
Exciting stuff. I mean, it's good. It keeps me up at night in terms of all the possibilities there. And we're going to illustrate some towards the end here.
And again, managing recording of trade and commerce, we talked about that a little bit now, right? We could tokenize, just like I have a title for my car, I could move that to a token and then sell my car that way. I can also put logic or rules as far as my token to subdivide it. So say, well, maybe not an automobile, but with these days with the prices of cars, it may be worth it. But we could take a property or land, and we can tokenize that, essentially bring the deed onto the blockchain. And it can be subdivided to 100 to 1,000, and we can all own shares of that land much, much easier. So we can obviously manage the number of transactions. We have real digital assets. So that's a little bit different from what you see today with the bank. Like when you go to an ATM machine, we'll see online our digital asset, what we think might be digital. That's a digital representation of a ledger entry, a centralized ledger entry, either at your bank or at the Federal Reserve. So that's not true digital currency, because you might say, well, we already have digital currency, right? We have credit cards and all that. It's a representation of a ledger, centralized ledger entry. So you might hear a little bit about Fed coin and all that, which would be a true digital currency that runs peer to peer on the blockchain. Obviously, operational management, we just talked about that, things like the DAO, where we can write applications on top of the blockchain, so a new layer on top of it, that allow us to embed rules, and that'll help us manage risk, because certain rules will be executed when we are in a business and when certain risks are encountered. And obviously, we want to be clear and transparent, and we'll have to build in rules in our application so we meet our obligations for regulatory and compliance.
It's a quick slide on smart contracts. If you can just talk about what that is, Jim, because I think
Smart
there's a lot of people have a
contracts.
notion of what it is, but
Well, smart contracts could be an agreement, carry out an agreement between two people. So the most popular example is what we call the escrow agreement, where we both agree, say I have a contractor and he's going to help me pour concrete for my porch. Well, I would upload a certain amount of cryptocurrency. We'd have a smart contract. The first part of the smart contract, I indicate that a certain amount of cryptocurrency has to be escrowed. So that'll be escrowed by the contract. And then as both of us, the contractor and me, agree that certain milestones are met, it can actually pay out that contractor coin by coin or bit by bit on a pre-agreed basis. So that's an application. Yes. Is it a contract? It's carrying out the terms of a contract. We can get into the legality, whether it's a real contract or not, but no courts, as far as we know, have ruled on them. It could be any day now that a court rules on them. And this also opens up a big opportunity for those that are good with source code, because courts, lawyers are going to need auditing, right? Regulators are going to need auditing of smart contracts, because this is going to be the first time. I mean, you think legalese is difficult. When source code has to be analyzed and adjudicated, right? That opens up another opportunity right there, where we say, okay, this is what this contract is doing. But in short, smart contracts are applications, just like Word or Excel. There is no user interface for them, but they're applications that are compiled onto the blockchain itself. So they are immutable. They're always up and running. They have their own identity on the blockchain, and then they typically carry out transactions, but they can do other things as well. And we can build layers on top, web servers and all that, where we build, like Ryan said, the DApps or the DApps.
yeah, and just to talk about what you're talking about lawyers earlier, it's funny. I always harken back to the Mad Men era and the billboards. Those marketers had to become digital marketers and growth hackers. The same is going to happen almost for every profession. We're all going to have this layer of technology that we're going to have to come familiar with, or at least have somebody on our team. So lawyers are going to be engaging with this before they're probably comfortable doing so, just because that's what the market will demand. So, whether you're an accountant, or a lawyer, or in the healthcare space, and, medical records are going to move in this direction as well. It's almost on every profession that deals with information to anticipate changes coming, and wouldn't hurt your profession or your own career track, knowing this sooner than everybody else. So we'll quickly get into some use cases, and I want to make sure Bill has some time to talk. And maybe Jim, I'll just run down these real quick. So I always encourage, there's some great books out there to kind of really open the aperture of what the possibilities are out there. But, we're the whole country, and not just our democracy, others are talking about voting. So if we can make voting more secure, I mean, right now, I don't think it's necessarily done on the blockchain, but it will probably be in the next iteration. But Estonia, they do 100% digital voting. And once you have this single source of truth that everybody's on the same page, that becomes more secure and easier to do from your mobile phone, maybe with facial recognition, to secure your vote and your one vote, right? And so real estate we talked about earlier, education, your records right now, if you graduate from CNM, they're going to want to, they hold your information, right? Typically, and Bill might be able to talk about how that's changing. And I think that's what he's going to talk about here. But the fact that you have to go to your doctor for your healthcare records, why don't you have them and you provide the doctors the keys for the information, the specific information? They don't need your whole medical history. Maybe they just need this sliver, and they'll ask for that, and you'll have a key, or at least the software will be able to issue it. And it's kind of like Google spreadsheets or others where you share access. That's what's coming down the pike here. And a lot of this stuff's going to be automated. Think about taxes. It's going to be automatically paid. So those that are good at hiding taxes might not be able to hide as well. So there's just a multitude of things. And, just like the internet, when it was birthed, we didn't anticipate all that would be coming. Heck, even 3 years ago, NFTs weren't, really a thing. So the additional use cases out there are still budding, and it's going to be an amazing time. You just hope it empowers more people and not less at the top. And that's kind of the distributed, decentralized nature of it that hopefully empowers the unbanked and everybody across the spectrum.
There are NFT restaurants now and NFT country clubs where you hold an NFT, and as soon as you're tired of being a member, you sell it to someone else. The club has nothing to do with it.
Right. Yeah. So it's just the ecosystem.
I mean, I just heard of it recently. I would never even have thought of that.
Right. Yeah. And somebody's thinking about it. In every single business, people, once they see the what this technology can do, they'll see it from their lens, right? They'll see the problems they're dealing with and go, oh, this fixes that problem. Or, this fixes that middleman that's kind of eating into the margin of everything. So, it is remarkable. Why don't, in the interest of time, we can talk about NFTs. Let's do a quick talk about NFTs, and then I want to give Bill some time to talk as well.
So yeah, NFT starts off as a token of what it does. It's a representation of either something physical or it could be digital. So either a video, an image, or a say music or sound. And what happens is we take that data and we're able to hash that data into a unique fingerprint. And we're able to add embed other data in there. So we describe what is in there. So it's all compressed. It's readable, but it's all compressed. And then the ledger states who owns it. And then you have a validation of your ownership, and you have validation of anybody whom you've given permission to use that. So if you want to come up with a Pop-Tart cat there or something like that, you don't have to sell it at a very inexpensive price to somebody and let them make all the money, which what used to happen not all that long ago, right, in the music business. So some of the superstar bands, I don't know if we really have them today, but if you think back not all that long ago, the superstar bands, like if you've ever seen Jersey Boys, now
you're dating yourself, Jim.
What's that?
You're dating yourself, Jim.
Yeah, maybe a little bit, but
I'm just kidding.
I don't go back that far. But the Four Seasons, they didn't really make any money until decades later, and that's because they were a classic rock band. But the music company made all the money. Well, you don't have to do that anymore. So with
you can make it directly from your fans, right?
Correct, right. So.
Yeah. So there's just the list keeps going. So you got to dive in. You got to have that paradigm shift in your own brain, and then see where you fit in it. Really. We'll talk about central bank digital currency, and then we're pretty much done. And Jim will open it up to you, or sorry, Bill will open it up to you. So central banks. I mean, this is a big thing, right? The U.S. dollar reigns supreme across the world, but we have already El Salvador and others coming in. Jim, can you take over? I got a toddler running in on me.
Yeah, no problem. Well, the thing with the central bank is, obviously there's an establishment. Right now, the dollar is obviously the world's reserve currency. Digital, I shouldn't say that. I shouldn't say crypto is not necessarily a threat. to that. I mean, they can live together or coexist together. So there can be also a central currency, which is still be the US dollar. And then you can also have a reserve asset. So today we have gold, we have silver. Those are reserve assets that any nation you can use. I mean, it's just not liquid, right? It's hard to walk around with bars of gold or gold coins. But so it's not necessarily a threat. There are downsides to fiat currencies, right? They can be overprinted, they can be inflated. Somebody controls them, whereas cryptocurrency, it's controlled 100% by the community. And there are strict rules about what creates more of that cryptocurrency. So it goes up really when the goods and services that it's backing go up. So when there's more goods and services, the amount of the cryptocurrency increases. And as long as that economy grows, if the supply grows at 5% and that economy grows at 5%, it'll retain its value. It shouldn't be inflationary or deflationary.
Yeah, so I'll just quickly talk. We're all living through disruption. So what is our challenge? It really is to figure out things before everybody else, right? In terms of us individually trying to succeed out there. I think you got to come in knowing all the problems that we've been trying to solve, but with the same solutions, not necessarily to get there. So we need to think about a new way of doing it. And so you come with your problems from your experience and background, and you'll see where this technology starts to solve some of that. It doesn't solve all the problems, right? We're not going to solve everything here, but it does bring a ton of efficiencies and new possibilities to our world. So there's also an opportunity cost. You do nothing. There's a lot of us that did nothing when e-commerce came out, but those that did quite well, right, with e-commerce. And then just thinking about the pace of change. We often think we want to accomplish this in 1 or 2 years, but over a decade, if we set the race long and we try to really accomplish something in a space, you can get it done. And it's remarkable what we can accomplish in a decade. I mean, the iPhone's only 13 years old and it's changed the whole world. Yeah. We have to figure it out before they do. We had some questions, but in the interest of time, Bill, why don't you jump in and share what you have?
Well, no, I'm okay for you answering the questions too. I just want to share real quickly that CNM is also moving forward with a state grant that we received to build out what's called the Blockchain Center. And in that center, we'll be developing things like real world solutions where we actually connect blockchain with IoT and data science to work on real world solutions together in what we call one of our technology solution labs. So you can come in and enjoy kind of the properties of working with mentors and working with instructors and potential work groups to work with the local community and actually build real world prototype solutions. So thank you, Ryan, for the brief time. I just wanted to throw that out there, and we'll talk more as we get into the evolution of that blockchain center.
Great, thank you so much. I'll get some questions here. What is IIT from Ari? Oh, IoT. Thank you. I should have expanded. So that's Internet of Things. So there's going to start to be chips and codes that are embedded in almost everything. So the more of these chips that can be scanned across supply chains and the like. Imagine this E. coli outbreak, and once we have these packages, we know exactly where everything goes. And as opposed to saying, hey, there's an E. coli outbreak, we need to pull produce from the shelves of 12 states across, and everything's got to be thrown out. Instead, we know which parcel of land that the issue came from, and where it was distributed to the end user, and it's a lot less expensive. So that's what Internet of Things is gonna. That's another Web3 property that's gonna work with blockchain and others to make the world a cooler place.
The blockchain also helps secure, because right now the Internet of Things is very unsecure. So the Internet of Things are really devices, small, large devices, all connected to the network. So there are even cars, tire sensors have their own IP address. But they can be hacked. We've all heard about baby monitors being hacked. Well, because there is no login name and password. So the blockchain can provide that in the form of a hash and very quickly and very efficiently. So there can be security and identities can be validated. So somebody doesn't go in and just cause problems with a tire sensor and then take over other parts of an automobile or even medical devices. So
Yeah. So just more security and efficiency awaits us so long as we're willing to learn and execute, right? So I appreciate the time. Those seem to be all the questions we received, but I encourage you to enroll in CNM's programs. They have a lot to offer, and you won't regret it because you'll have the skills that are really in demand and are certainly going to be in demand even more so in the future. So we thank you for your time, and we'll have this recording saved should you want to view it later. All right. Thanks so much.
Thank you so much